Hello, everyone. Today we're going to talk about a rhombus or rhombi, which is rhombus plural. So, definition of a rhombus is a parallelogram with two consecutive sides congruent. So, a rhombus is a parallelogram. So, again, if we name this rhombus R H O M, since it's a parallelogram, that means opposite sides are parallel. So, RH is parallel to MO. And RM is parallel to HO. Opposite sides are congruent because it's a parallelogram. So RH is congruent to MO, and RM is congruent to HO. Opposite angles are congruent. So angle R is congruent to angle O, and angle M is congruent to angle H. Consecutive angles are supplementary. So again, that means that R plus H equals 180. And then last but not least, our diagonals bisect each other. So RO and MH bisect each other. Now, knowing that it's a rhombus, I know a couple other things. So I know that all my sides are equal. So RH, HO, MO, and RM are all equal. If it's a rhombus, all sides are equal. And then I also know that the diagonals bisect the angles. So that means this green line here cuts angle R into two angles that are equal. And it does that to all the angles. So these two are equal, and then these two are equal. And then last but not least, the thing that's the coolest that we're going to use the most is that the diagonals are perpendicular. So that means there's a right angle here. All these are right angles. So RO is perpendicular to MH, which means we can use the Pythagorean theorem. So to prove a quadrilateral is a rhombus, we need to show it's a parallelogram with consecutive congruent sides, so sides that are next to each other, or a quadrilateral with all four congruent sides. A parallelogram whose diagonals are perpendicular, or a parallelogram whose diagonals bisect the angles. We're still going to focus mostly on finding missing parts. So let's look at number one. So the first thing I see in number one, since I know this is a rhombus, is I know that angle 2 equals 90 and angle 3 equals 90. Because remember I said the diagonals are perpendicular. Now, to find the other ones, I need to remember that my diagonal cuts the angle in half. So that means angle 4 equals 59, which also means angle 1 equals 59. Because the angles across from each other are always going to be equal. So now I'm going to use that to help me do number 2. Because in number 2, the angles across from each other are equal. So angle 2 equals 68. Angle 3 equals 68. Angle 4 equals 90 because the diagonals are perpendicular. So now to find 1, I need to do a little bit of work. So to find 1, I need to realize that right here, I have a triangle. And this is a right angle here, and I know 2, so angle 1 plus 68 plus 90 equals 180. And so that tells me that angle 1 equals 22. So I want you to pause. And I want you to try to do 1 through 4. And then come back and we'll discuss. Okay, so number 1, ABD is 60, which means BDC is also 60 because they're alternate interior angles, or the angles across from each other are equal. I know AE equals 8. So if AE equals 8 in number 2, that means AC equals 16 because it's 8 times 2 because the diagonals bisect each other. Then I know AD equals 2x plus 4 and CD equals 4x minus 4. Well, it's a rhombus, so that means AD and CD are equal because all sides in a rhombus are equal. So 2x plus 4 equals 4x minus 4. So that means I subtract 2x. 4 equals 2x minus 4. 8 equals 2x. So x equals 4. CEB, that's in the middle here, so that means that's 90 degrees because the diagonals in a rhombus are perpendicular to each other. So I want you to pause and I want you to try 5, 6, 7, and 8. All right, so 5 is a little trickier. So let's look at 5. So we know CBD is 58. And this is a right angle. And I'm looking for ACB. So I want this side. Well, that up there is a triangle. So since it's a triangle, that means x plus 58 plus 90 equals 180. So that means x equals 32. For 6, AE equals 3x minus 1, and AC equals 16. Well, AE is half of AC. So that means 3x minus 1 equals 8 because I took half. Add 1, 3x equals 9, so x equals 3. Then CDB is 6y. And ACB, CDB, and ACB is 2y plus 10. So this one's trickier because to do this one, you got to remember that our diagonal AC cuts our angle in half. So if this side's 2y plus 10, so is this side. And then I have a triangle here where this is a right angle. So it's going to be 6y plus 2y plus 10 plus 90 equals 180. So that's 8y plus 100 equals 180. Subtract 100. 8y equals 80. So y equals 10. Number 8, AB equals 26, BD equals 20. And I'm looking for AE. All right, so I'm going to erase some stuff up here. I don't want to erase all that. So I know what they just told me on number 8 is that AB equals 26. And BD equals 20. Well, AC cuts BD in half, so that means BE is 10. And then if I look right here, I have a right triangle because this is a right angle. So if I'm looking for AE, that's one of my legs in my right triangle. So 26 is c. So I'm going to do a squared plus b squared equals c squared, the Pythagorean theorem. So it's x squared plus 10 squared equals 26 squared, because the right angle always has to be across from the hypotenuse. So it's x squared plus 100, because I square these first, equals 576. That's what 26 squared is. Sorry, not 576, 676. I subtract 100 from both sides. So x squared equals 576. I then take square root of both sides. And x equals 24. So AE is 24. So that's the end of our video today. We'll do number 9 in the extra practice tomorrow in class.